All right, so here's problem number one. So we have 20 grams of vinegar, and vinegar is the same thing as HC2H3O2, and that's producing H plus and C2H3O2 minus. So this equation is in equilibrium, and so we're gonna solve for the pH of vinegar in this instance. So we have 20 grams of vinegar, and the Ka is 1.8 times 10 to the negative fifth. So first of all, we have to figure out the amount of moles that we have of vinegar. So we need to figure out first what is the molar mass of vinegar. So we know that vinegar, 1 mole of vinegar is the same thing as the sum of all these molar masses together. So we get 1 plus 2 times 12 plus 3 plus 2 times 16. So that is the mass, because we're going to add up all the elements of vinegar. So we end up getting the molar mass of vinegar is 60 grams per mole. And that gives us 1/3 of a mole in this problem. So let's set up our ice chart. So in the beginning, in the initial, I forgot what the I standed for a second. So the initial. So the vinegar is 1/3, and the H plus, that's going to start at 0 because we haven't done anything yet. And then the C2H3O2 minus, that's also going to start at 0. So now for the change, well, we're going to subtract X, because over here, X will be added. And X is the concentration of H plus, which we're going to solve for in a second to find the pH. Okay, so now we have to just add the initial and the change to find what we would have in the equilibrium. So we have 1/3 minus X, and then X, and then X. So to find the X value, to find the concentration of H plus, which we will use to calculate the pH, we have to use the Ka value. So the way we do it is we set it up as Ka is equal to the products of the products over the reactants. And so both of these are X, so it's going to be X squared over 1/3 minus X. And X here is such a small value that we can basically just ignore it, so I just cross it out. So that gives us X squared over 1/3 is equal to 1.8 times 10 to the negative fifth. And so from here, it's just a simple math problem. So X squared over 1/3 is the same thing as 3X squared. So 3X squared equals 1.8 times 10 to the negative fifth. So we can just solve X squared equals 6 times 10 to the negative sixth. And then X is equal to 0.0025. So that is the that is the concentration of H plus that we have. And remember, pH is the negative log of that. So it's whatever 10 to the negative power of what is equal to this value. So that's how we find pH. So we can just do we can just do negative log of 0.0025, and we get pH is 2.6, and that is your final answer. All right, let's move on to question number 2. Okay, so here's problem number 2. So we have C3H5OOH, and it is making H plus and C5H5OO minus. And so it's in equilibrium. And we have 0.2 moles of C3H5OOH, and the Ka value is 1.3 times 10 to the negative fifth. And our job is to find the pH. Okay, so let's set up our ice chart. So we have the C3H5OOH starting out with a 0.2, and then the H plus and the other product is going to start out at 0 for the initial. And then for change, okay, so we're going to subtract X, and we're going to add X and add X again. So X is the concentration of H plus that we're going to solve for later to find the pH. So then equilibrium, that's just the initial plus the change. So we're just going to get 0.2 minus X, and then X and X. So yeah, pretty straightforward. Okay, so now we're going to solve for X. So Ka is 1.3 times 10 to the negative fifth, and that is equal to the products of the products, the concentration of the products multiplied together over the concentrations of the reactants multiplied together. So since both of these products are the same, it's going to be X squared over 0.2 minus X. And now for this problem, we're going to assume that that the concentration of H plus over the acid is less than 5%. And so normally if it's less than 5%, you can just ignore the X. So for this one, we're gonna assume that it's above 5%. And so that means we're gonna have to solve it out. We can't ignore the X, and we're gonna use the quadratic equation to solve it. So we get 1.3 times 10 to the negative fifth times 0.2 minus X is equal to X squared. And then we're just gonna distribute everything over here, and we're gonna move the X squared over to make it X squared plus 0.000013x minus 0.000002x equals 0. And we can use the quadratic equation to solve for X. And so X is equal to negative 0.000013 plus the square root of yada, yada, yada. You get the idea. So we're just using the quadratic equation to solve for X. And eventually we're going to get X is equal to negative 0.001619 and X is equal to positive 0.001606. And obviously the negative value doesn't make any sense because you can't have a negative concentration. So I just circled the positive concentration, and that's the one that we're going to use to calculate pH. So pH is the it's a measure of how many hydrogen ions you're creating. So negative log of the constant of the moles of H plus is pH, because we're trying to figure out 10 to the negative what is equal to that concentration. So 0.001606, that is the concentration. So we're going to do negative log, and we get pH is equal to 2.79. All right, that's our final answer. And now we're going to talk about what changing the amount of products and reactants and changing all the conditions, how that would affect the equation. So if we increase the pressure, let's say we'll go back to problem 1. So if we increase the pressure of an equilibrium, it's going to shift towards the side that has less moles. So if we increase the pressure, now then it's going to shift to this side, because this side has less moles than this, because there's an imaginary one right here and here and here. So this side has 2 moles together, and this side has 1. So it's going to shift this direction. So that would happen if we increase the pressure. Now, if we increase the volume, that's going to decrease the pressure. So in turn, it's going to shift to the side with more moles. So if we decrease volume, it's going to shift to this side, because this side has 2 moles versus 1, and that's greater. So now if we increase the pressure, that's going to increase volume, and that in turn will decrease pressure. So then it's going to shift again to the side with more moles. So it's going to shift to this side. So yeah, that's how that would work.